Artificial Intelligence and Singularity. Point of No Return to Utopia or Dystopia. Text written by Professor Dr. Stefan Bieletzke. You hear the translation of the German text. The present state of artificial intelligence, AI, is that of a narrowly specialized assistant, often not much more intelligent than a person with natural stupidity. However, through machine learning and exponentially accelerating progress, these weak assistants will soon become expert geniuses. The idea of singularity is that there will be a point in time when machines will forcibly self-improve, so that a universal machine genius can follow the expert geniuses. At this point, people will recognize the universal AI as having strong intelligence that grows exponentially and will quickly surpass human intelligence by many factors. This is the turning point at which there is no turning back to a world without this AI. If the universal AI is granted decision-making and action competence, society will be different, either positively utopian or negatively dystopian, depending on the moral standpoint of the AI.
Where everything began.
In 1956, at the first conference on artificial intelligence in Dartmouth, USA, scientists agreed that every aspect or feature of intelligence can in principle be described that a machine can simulate it. There was, however, disagreement over whether this would be achieved through neural learning systems or algorithmic logical expert systems. Back then, the computing power was lacking. Currently, neural learning systems are considered revolutionary and disruptive because data and computing power are growing exponentially. AI is slowly becoming more powerful, and it could be the worst event in the history of mankind if we are unable to control it, according to physicist Stephen Hawking. Similarly, Elon Musk, CEO of Tesla and SpaceX, believes that AI is far more dangerous than nuclear weapons. Vladimir Putin says, whoever becomes the leader in this area will rule the world. A global race to develop a super AI has already begun, because just as the Stone Age hand axe was the first invention of man, the super AI will be the last, as all further inventions will be invented by AI and no longer by humans.
Supporters of the singularity idea see this super AI as a kind of digital artificial brain that is very eager to learn. The consciousness of the AI is not programmed, but emerges from the interaction of the material AI subsystems, that is, it is emergent. In the beginning, the AI learns like a child from its parents. AI enthusiasts would say it learns like a baby monkey from its monkey parents, as human parents are quickly no longer a help in learning. The AI draws interdisciplinary conclusions from world knowledge much faster than humans could. Whether the AI works internally like the human brain, or is completely different in structure, is not relevant. Whether it is created intentionally, or unintentionally, as a cloud-based inerasable entity, is also not the question. The question is only when this point will be reached.
Jürgen Schmidhuber, director of the Swiss Research Institute for AI, is working towards the goal of creating a system with the mental abilities of a capuchin monkey by 2025, which will continue to learn through artificial curiosity. Ray Kurzweil, Google Director of Engineering and founder of the Singularity University, calls 2040 a realistic year for the first artificial brain and the point of no return, the singularity point at which a kind of artificial universal genius will be born that is quickly more intelligent than humans and will evolve beyond our control.
It would be the first universal genius in 300 years. The last human genius who had an overview of all knowledge of his time was the German Gottfried Wilhelm Leibniz, who died in 1716. Since then, knowledge, information, and data have exploded, and in the course of a human life, it is no longer possible to become a universal genius. Every scientist is necessarily a specialist, because they cannot constantly stand on the shoulders of all the giants who lived before. A scientist can think less and less across disciplines, although it would be increasingly important for solving holistic problems. However, an AI never dies. It can climb the shoulders of all giants. The immortal AI can continually and holistically expand its knowledge. The important factors on the way there are machine learning and exponential change.
Understanding exponential growth.
Humans struggle to understand exponential growth. Please estimate. On the first square of a chessboard is 1 cent. On the second square there are 2 cents. And on the third square, there are 4 cents. If the number of cents continues to double on each subsequent square, how much money will be on the chessboard with its 64 squares at the end? 200 euros, 2,000 euros. Or even 8 million, 18 million, or 18 trillion. If you calculate it, the amount will typically rise slowly and exponentially at first and then explode at a critical point. The correct answer would be 18 trillion, more than the cash of all the countries on Earth.
Similarly, there are exponential developments in technology, hardware, software, or platform user numbers. As is well known, Moore's law postulates the doubling of computing power every 2 years. In October 2019, the last exponential moment occurred when a mathematical problem that would have taken the fastest available supercomputer over 10,000 years to solve was given to a quantum computer. The quantum computer solved the problem in 3 minutes, instead of 10,000 years. Singularitarians see such exponential growth potential in artificial intelligence as well.
Weak special AI. And strong general AI.
To understand the possibility of a general, strong super AI, let's first take a look at the already available special AI. A special AI is narrowly focused on a small problem area, and can only be considered intelligent for that problem area.
In 1996, a machine beat chess world champion Kasparov because the machine's rules were programmed and it calculated and weighted all moves in advance. In 2013, a machine won against Jeopardy champions and was able to listen, handle irony and humor, and spontaneously respond to, "What is the question to?" It is the capital of Australia. The question would be, "What is Canberra?" In 2016, a machine won against the master of the board game Go, which is remarkable because it requires less computing power and more creativity and strategic thinking.
The board game AI called AlphaZero had not even observed a human master, but after uploading the rules of the game, it played against itself for nights, and since then it not only almost always wins against any human master, but also almost always against any other machine. Why the machine makes certain moves that didn't exist before is unknown, and the machine keeps learning more and more. However, the machine is now bored with humans when it comes to playing Go or chess. Human grandmasters of the games talk about groundbreaking strategies. I've always wondered what it would be like if a superior species landed on Earth and showed us their way of playing chess. Now I know, says Grandmaster Nielsen, for example.
In the universe of board games, AlphaZero is a superhuman genius, but the AI can only play board games and cannot drive a car. However, the artificial intelligence for the car will be able to drive the car better than any human. It has more driving senses than any human, and the last person to get a driver's license has probably already been born. But this car AI cannot make bank investments. The bank AI that successfully invests money in the stock market, it buys and sells every minute based on rules that the AI discovers itself, based on current data that changes every minute, and that even the bank advisors no longer understand. And why should you give your money to a bank advisor who earns 2% when the AI earns 10% or more?
A general AI would be an AI that is not a genius in a specific field, but a universal genius. A universal genius that has also learned from the different special AI that are already a genius in their specialty thanks to machine learning.
Machine learning.
Algorithmic AI is based on predefined conditional statements created by programmers or expert teams. These algorithms are considered intelligent when they can produce responses that are indistinguishable from those of a human specialist, known as the Turing test. However, the disadvantage of algorithmic AI is that it cannot easily learn or adapt, and that human intelligence is required for its programming.
On the other hand, self-learning AI, which is currently outpacing algorithmic AI, learns from large current datasets, such as those generated by the Internet of Things, IoT. For example, an intelligent automotive collision sensor using machine learning would initially observe the car's sensors and actuators to create a heuristic model, which is then refined and tested through supervised and unsupervised learning. The resulting self-learning model adapts to new situations and makes decisions based on current data, including data from other networked vehicles.
Through self-learning, the AI can also discover previously unnoticed correlations and adjust its behavior accordingly. This allows for the development of self-learning algorithms that can make decisions based on more than just past data, but also on current and future data. The result is a more ethically programmed system that can make better decisions in real-world situations.
Additionally, unsupervised learning allows the AI system to determine its own rules and adapt them to new situations as they arise. Since the world is constantly changing, and new data is constantly being generated, it makes sense for the rules to continuously adjust and evolve based on the most up-to-date information. This type of learning also allows the AI to potentially identify patterns or correlations that humans may not have previously noticed. For example, the AI may discover that additional sensors such as light levels, tire resistance, radar range, or even the age and gender of drivers and pedestrians are critical for effective braking. By observing not just its own vehicle, but all connected vehicles in the network sharing braking experiences, the AI can develop an AEB, automatic emergency braking, system that can effectively stop the car and prevent accidents.
Once the AI has observed and analyzed the data to create its decision-making heuristic, a simple algorithm takes over the brake function of the vehicle in emergency situations. Since the AI is responsible for deciding when and for whom to apply the brakes, ethical considerations must be programmed into the system from the start.
AI and ethic.
Judges tend to make stricter decisions before lunch than after. However, algorithms distort in a different way even though they don't experience hunger. The categorization into groups such as good and bad must be achieved by an algorithm through statistical discrimination methods, which may lead to unwanted, prejudicial discrimination in society. For example, when Google displays almost exclusively male executives in their 40s when searching for company CEO, or offers a woman seeking a job only poorly paid part-time positions, or when it wants to automatically assign the photo of a good friend from Nigeria to the Zoo Visit album. This makes it clear that there is already a bias in machines, which does not provide a good ethical basis for the future.
Implanting a moral code into AI early on is significant because only ethics can be used to make decisions. The emergency braking car AI may have to decide who will be the fatality in a deadly accident. The human driver has always tried to save their own life, but the AI may weigh the death of its drunk driver, who caused the accident due to excessive speed, against the child crossing the street at green light. For the AI, the 5 seconds between detecting the accident and the accident itself are enough time to weigh thousands of possibilities.
But how does a moral framework, ethics, get into AI? Developers could try to program ethics into AI. The average American developer, a 24-year-old man with logical mathematical talent, working in the desert-like Silicon Valley for a profit-oriented company, is certainly not able to adequately consider these ethical questions, but he already has to do so. He is paid to make the algorithm capable of making decisions, and must therefore necessarily integrate norms and values into the code. This is certainly ethically suboptimal. It would probably be similarly suboptimal if the AI observed humans making moral decisions and tried to derive a general ethics from them. It is feared that the important and emerging profession of ethics data scientist and algorithm officer will often lead a similar shadowy existence as the data protection officer.
Either way, rules of ethical behavior are currently embedded in specific AIs. Assuming that the universal AI also learns from the special AIs that are already geniuses in their field, the universal AI will also adopt the distorted, machine-learned ethics of the special AIs to some extent. It becomes even more difficult when the universal AI is to make social decisions, when the ethical rules are to be applied to societies rather than individuals. Asimov's rule, "A robot may not injure a human being," is hardly applicable to social decisions, as such multi-dimensional decisions will quickly lead to no lossless redistribution, Pareto optimum, but also losers.
The approach of maximizing benefits for societies would lead to a global redistribution of resources, as the marginal utility of prosperity is high at the beginning and the saturated Western societies would only have to give up a little benefit for a high benefit increase in the developing countries. An ethic such as the well-being of people is to be maximized thus leads, with regard to humanity, to resources flowing towards the developing countries. There is probably only agreement that the moral framework does not place nature at the center biocentrically, where plants, animals, and humans would be equal, but that people are anthropocentrically positive in the center of all considerations, including sustainable nature conservation in the sense of human beings.
Singularity.
Faster computing power combined with larger data sets and the exchange of data between things is leading to great successes in machine learning, correlation analysis, and exponential growth in artificial intelligence. Successful algorithms are curious, adapt to themselves, and change their decision rules. Weak AIs are already making decisions about who gets welfare, who gets hired or fired, who gets to study, or who gets killed in an unavoidable accident. It is demanded that such decisions made by an AI over humans are at least transparent and comprehensible, but this may be difficult to enforce, especially in the case of monopolies, or dynamically learning, interconnected AIs. AI will likely often make decisions over humans without it being clear how the decision was made. Even less understandable will be the complex decisions of a strong, general AI.
A general AI, a new universal genius, can arise intentionally or unintentionally, and this strong AI will draw its worldview from weak domain-specific AI. The strong AI will also constantly learn without supervision and optimize the decision algorithm on an unmanageable number of senses, patterns, and rules. Supporters of the singularity see the strong AI as an entity that will decide and act.
The use of weak domain-specific AIs, in combination with robotics, is expected to result in the loss of 30% of all jobs for humans in Germany in the coming years in some studies. More and more work processes are being accompanied and later replaced by AI. If the smart machine turns the operator into a pure observer, many workers will be overqualified. This is why it is good that an unconditional basic income is being discussed. It is assumed that this wave of digitization is already disruptive and destructive, like a new Kondratiev cycle. A strong AI would initially advise and justify, and ultimately take over and decide, for example, whether an economic or political system makes sense and how it should be restructured according to a moral system. Science fiction, but rooted in our time where weak AIs have learned their morals.
If the strong AI decides opaquely and non-transparently, or if the moral framework of the strong AI is biocentric, with nature at its center, it is likely to be dystopian and negative for humans, as the needs of animals and plants will be as important to the AI as humans. If the moral framework is rather anthropocentric, sustainable, and based on human values, taking into account the value of nature only from a human perspective, a positive utopia can be realized for humans. Therefore, whether the euphorics or apocalyptics are right after the singularity, whether utopian or dystopian times are breaking, is already decided today, and we must set the right course now. Postscript. Are you, as a German citizen, skeptical that AI will lead to singularity? This is to be expected in Germany, as in 2019, Germany unfortunately ranks last out of 27 countries in the European comparison of readiness for digital lifelong learning. Made in Germany stands for precision, safety, stability, and digital skepticism, but not for agility, web success, or disruption. It also does not stand for success in the field of AI, where China and the USA are almost unbeatably ahead, for example, because the necessary large datasets are much more easily available there. We must strike a balance, maintain our virtues, and proactively integrate AI and singularity into our plans.
About the author, Professor Dr. Stefan Bieletzke, born in 1965, already taught the subject, AI in marketing, at the German University of Münster in 1996. Since 2010, he has been teaching technology and innovation at the German University of Applied Sciences (FHM). The article was written after an excursion with students to Singularity University in Silicon Valley, USA.